So we're moving on to the next topic, inertia. Inertia we covered last fall in ISBIT 112. We used its cousin called momentum, and of course the physics idea of inertia is that something that's large and massive that's moving in a particular direction is very difficult to change its direction. We often use the example of the Titanic, that of course had a very famous movie made out of it. It sunk over 100 years ago in 1912. The idea was that it was steaming really, really fast through the ocean, headed to New York on its maiden voyage, and the lookouts noticed that there was an iceberg ahead, and they shouted for the big ship to make a change and to change either left or right. And it tried to do that, but it just couldn't change fast enough and ended up slamming into the iceberg and then eventually sinking, as if you've seen the movie. Sorry, spoiler alert. But the same analogy holds for businesses as well. In fact, we'll use that analogy. We'll say that a business was not agile enough, or it was not nimble enough to make a course correction. Whenever a new technology came out, they couldn't respond to it fast enough, and then they sort of crashed and burned, unfortunately, is the analogy that we use. So typically, hopefully, a company that is designed properly will have its own research and development department internally. It will be really smart and say, hey, I think I know what the next version of this product is, and then they are the ones who invent it. However, if you're not that company, or if that company is not the one you're working for, the idea is that once a new product comes out, hopefully that company is designed systems-wise to make an adjustment very, very quickly. So inertia can be a problem. It can be a pitfall. And unfortunately, in this case, it causes a delayed reaction to technological breakthroughs. And the example, just like we used Caterpillar in the previous section, the example in the textbook is the Continental Can Company. It's a lovely, lovely, I guess they could call it 3C, sort of like 3M, the Minnesota Mining and Manufacturing Company. Back in its heyday, it had 500 factories. So 500 factories is quite a bit. You can imagine that each of these factories may have had, 100, 200 employees, and multiply that by 500. That's a lot. They didn't make all of the cans in the United States and the world, but they had a 45% share of those individual cans. And of course, we have to go back technology-wise and refer to it as the three-piece can market. So what the heck is a three-piece can? So here's a three-piece can. Now, of course, I didn't know until I looked it up. A three-piece can happens to have, regardless of what the material is, whether it's aluminum or tin or steel, there's sort of a seam right here. You can see that there's sort of a rectangular shape that is rolled up into a cylinder. And then there is a base that is crimped on the bottom, and then you fill it, and then there's a lid that's crimped on the top. So then you have a full metal can. What are you putting? Soda inside there. You're putting green beans inside there. You're putting tennis balls inside of there. Not so much Pringles chips. Pringles chips is a cardboard can, and it has a plastic lid. But this is what a three-piece can looks like. And of course, the Continental Can Company made a bunch of them because we store a lot of things inside cans. Unfortunately, they did not invent it, but a different company invented something called the two-piece can. And if you look at this pretty quickly, you'll notice right away this really is what we use now. This is the modern version of a can. This sort of looks like a soda can. I can sort of imagine cutting a Coke or a Pepsi can in half. So what's happening now, rather than having a rectangular piece of metal and then rolling it up and then welding or crimping a bottom to it, it turns out that the design was to take a sort of a circular piece of metal and put it onto a machine that punches a hole down the middle. So try to think of an analogy I can use, sort of like someone who's making a pizza. If you take a round piece of pizza dough, can't even do it with my hands. You take a round piece of pizza dough and then you punch up through the pizza dough, and the pizza dough will sort of fall down over your hand. You have this long tube with your hand at the bottom. Well, that's what's happening here. So you can imagine we take this round piece of metal, and then we take this metal piston and push it down in the middle, and the sides fall up. So now we have a can whose bottom is part of the sides. There is no need to attach the bottom. So right away we have one less part to worry about. We don't have to worry about crimping it. We don't have to worry about welding it. We don't have to worry about attaching it. So now we just have a bottom and a top, whereas before we had a side, a bottom, and a top. So we had 3 pieces. And of course, it was much less expensive to make a 2-piece can. Unfortunately, the Continental Can Company, with all of those factories, they had very, very heavy machines that only made 3-piece cans. That's unfortunate. So it turns out that only took 3 years for the Continental Can Company to go bankrupt. There's lots and lots of examples like this. One of them might be Blockbuster. So Blockbuster had a whole bunch of VHS tapes, and then DVDs came out, and Blockbuster was very able to very quickly turn into a DVD rental store. And then, of course, streaming came out, and then when Netflix finally came out, they had the red box for a while. And then Blockbuster just went away. Blockbuster could not compete against Netflix. They was still a movie rental place, but of course it was the packaging, if you will. So analogy wise, the 3-piece can is perhaps a VHS tape. The 2-piece can is perhaps a DVD, and then just having soda on tap in your house, of course, would be streaming. We actually have machines called SodaStream, but they haven't taken over yet. So a company like the Continental Can Company definitely needed to embrace new technology and didn't, unfortunately, and that made them go away. Suboptimization. So suboptimization can be sort of a difficult thing to talk about. There's lots and lots of ways to describe it, but I think it's pretty obvious. The problem with sub-optimization, everybody loves to optimize. Everybody loves to make things better and make things more efficient. And we love innovation. But it turns out that it's not true that if something is good, like if X is good, X just means unknown. If something is good, then more X must be better. I'm trying to think of lots of different examples. So let's go back to the cell phone again. So let's say your cell phone comes with, I don't know, some sort of memory card or SD card where you can stick in, I'm just going to pick a number, 128 gig of expandable memory. That's fine. That's lovely. And then someone says, you know what? 128 gig is lovely, but it'd be awesome if we could have 128 terabytes of memory inside your phone. And that's fine. That's definitely more. It'll probably take the cost of that phone to go from 128 gig to 128 terabytes. That's 1,000 times more space. So I guess you can imagine that something now costs 1,000 times more. Nothing that huge, but imagine a $1,000 phone, a $1,000 smartphone with 128 gig of memory now costs $30,000 because of all the memory that it holds. And of course, I'm going to eat my words. In a few years, of course, everyone will need terabytes and terabytes and terabytes of memory because that's where we're headed, but just not now. I'm trying to think of another example. Another example might be an automobile. So let's say we have a car manufacturer. Let's say we have the new Corvettes look pretty nice. They sort of look like a new Lamborghini. If you've seen the new 2020 Corvette Stingrays, they're pretty cool. But imagine rather than having I don't know what it has, maybe 550 or 600 horsepower engine. What if the engineers said, you know what, let's put 1,000 horsepower engine inside the Stingray. That'll really make it awesome. So they go ahead and they cram 1,000 horsepower into a car, but they don't upgrade the brakes, so now you can't stop. They don't upgrade the transmission or the suspension or the steering. So all of a sudden you go ahead and you floor this 1,000 horsepower car, and all it does is just make the internals explode because it just can't handle that much horsepower. So the idea is this idea of sub-optimization is that if you are improving a system, make sure that you improve all of the parts or most of the parts, or anything that you do improve, you also improve the parts that it most directly touches. If you only improve one part, it's not going to be good. I'm trying to think of how about skipping leg day for 47 years? All you do is just upper body workouts, and you come around and all you have is chicken legs. It's not very good. So anyway, craftsmanship and productive detail. Let's just say led to difficulties for IBM, International Business Machines. In fact, they were so gung ho at increasing hard drive space and regular things for computers, but they didn't usually do things very balanced. They've eventually got out of the game. You know that they finally sold their trademark PCs to Lenovo. Texas Instruments, you may still have been required to grab a TI-85 or a TI-135 calculator in high school. Texas Instruments was sort of the rage before we had smartphones, and again they've started coming out with calculators that were supercomputers, and you didn't need them. All you needed to do was add, subtract, multiply, divide, and do a couple graphs. Same thing with Apple. This isn't a slam on Apple, and same thing with car companies like General Motors. All of these things listed here in the past have had trouble with trying to optimize things as they go. So it turns out that one of the similar things that is useful in talking about sub-optimization is this parable or this story called the tragedy of the commons, and it sort of fits in there. The idea is that if you happen to have a common resource, and that fits into what we're talking about in this, but if you happen to have a common resource and you go ahead and use this resource, if you use the resource at the level that you need it, that's fine. But if you go ahead and try to get ahead, like, oh, by the way, I'm going to take more than I really need to sort of stock up. If everybody stocks up, oh, I don't know, it's the COVID. If everybody went to Walmart or went to Target and started buying toilet paper so that they had enough toilet paper for the next 5 years, which is what they did, we would run out of toilet paper. So it turns out that the toilet paper issue that we're having now, or at least now we're replenishing it. We're not running out of trees. Toilet paper is made in the United States. It's not as if we can't get it imported. We have plenty of toilet paper. The problem was that everybody made a run on it. And this falls into this idea of the tragedy of the commons. And it's the same thing as sub-optimization. So all of our lovely compatriots here in the United States decided that they would sub-optimize the amount of toilet paper they have on hand so that they have a 6 month to a year supply. And they all went out and they grabbed it, and now there's not much left. And large box stores are slowly. It's taking a while for all these big trucks to bring all these toilet paper back in, but now they're limiting it to 1 or 2 packages rather than let people move things through. So let's take a look at this and see if I can get this guy to work.